So then let's move on to adjacency matrices. So adjacency matrices, again, another way of presenting information in a network graph in matrix form. Now you may have already seen these when you were covering matrices. So all that they are really is a way of converting information. And there's two separate types. So there's either undirected graphs, remember? Undirected graphs don't have any arrows. And then we also have directed graphs, which have a specific direction associated. So for an undirected graph, the way that you draw an adjacency matrix is you just draw the, so you work out the different edges, or the different vertices, I should say, and you just write them on top and also on the side. And then basically what you do is you look at the connection. So looking at A, we have a connection to C and we have a connection to B. So going along the column, just put a 1 next to the vertices that A is connected to. So it's connected to B and it's connected to C, so I'll put a 1 there. And you'll put a 0 where it's not connected to anything else. So 0 and a 0. Next, looking at B. So B is connected to A and it's also connected to itself. So I'll put a 1 here for A. And the reason why we put a 2 here, because remember, a loop counts as 2 separate edges. Oh, wait. Sorry, I think there's something wrong with this network. The 2 should be here. Sorry about that, guys. Yeah, so the 2 should be there. And then looking at C, so C is connected to A, it's connected to D 2 times. So you should have a 1 here next to A and a 2 next to D. Okay, I think these 2 columns were sort of swapped. There should be a 0 here. And then finally looking at D, D is connected to, sorry, I don't know what is wrong with this network. Sorry, this adjacency matrix. The numbers are all messed up. I'll just draw a new one for you guys so no one gets confused. So A, B, C, D, A, B, C, D. So looking at A, it's connected to B and it's connected to C. So B and C, and I put a 1 there because it's only connected through one edge to B and C. And then looking at B, it's connected to itself, and I'll put a 2 here because it's a loop. And then it is also connected to A, so I'll put a 1 here. So 0, 0. Then looking at C, it is connected to A, and it is also connected to D twice. So I'll put a D. I'll put a 0, 2 here. And then looking at D, so D is connected to C 2 times, and the rest is 0. Cool, so that is our undirected adjacency matrix. Now what about directed? So directed, it's really important to have a to and a from. So it looks the same as your undirected network, but you do have a to and a from here. So the to tells you which vertex you're looking from. And the to we also always place on the top, and the from always on the side. So basically the way that I read this is, if there's like a 1 here, what that means is that this vertex, the 2, has a connection to the C. So A has a connection to C, if there's a 1 here. If there's a 0 here, what that means is that A does not have a vertex, an edge going directly to D. Okay, so it's really important for this one because the direction is really important. This one, what this means is it's going from C to D and D to C, both ways. Whereas this one, for example, this edge over here, it means that it only goes from D to C. And then this one means it's C to D. Whereas this one, it's only C to A. So someone can go from C to A, but they can't go back because there's no edge going from A to C. Yeah, so basically that's all we do for this one. So I hope that makes sense. Again, let me know if you have any questions in the chat.